Good morning, everyone. This is Prahlad Rao, and thank you very much for joining the webinar today. This webinar title today is Managed Database Services on Amazon Web Services. As we all understand, designing the right database architecture for your application is critically important. Today's agenda will focus on looking at various managed database services on the AWS platform. We'll review configuration, features, and cost for each of those database options. We'll take a look at non-relational managed database through Amazon DynamoDB, relational managed database, which is our RDS platform, managed in-memory caching solution based on Redis and Memcached, which is our Elastic Cache solution, and finally, a managed data warehouse solution that is our Redshift platform. So typically when we are running in a cloud or a hybrid cloud environment comprising of your own data center and cloud, you have various options of running and managing your databases. One is the self-managed database, in which case you are responsible for managing the hardware, operating system, security updates, and everything related to the database. You also have full control over your database, including the underlying infrastructure. This is typically within your own data center or on-premise. On the AWS cloud, you can host your database on EC2 instances, in which case you only need to focus on the database level updates, database configuration, replication backups, and then don't have to worry about managing the underlying hardware or the underlying infrastructure. So you get benefit by simply moving your database from your own data center to AWS cloud and running it on EC2 instances. However, in addition to that, you also have a fully managed database solution on AWS where you get complete features such as backup, replication, managed database service that all comprise as a complete package, and you don't have to bother about managing not only the underlying aspects of hardware operating system, but also any undifferentiated heavy lifting from a database administration such as patching, backup, and recovery capabilities. So what are the different various AWS managed database options? So let's take a look at each of those. Amazon DynamoDB provides a NoSQL database based on document and key value store, where you can typically host any key value data store or JSON-based data store on DynamoDB. Amazon RDS provides a managed relational database hosting experience where you can run any traditional relational database engines such as SQL, Oracle, MySQL, and other database engines. Amazon Elastic Cache, which is based on in-memory key value data stores, provides option for you to run key value data stores in memory based on Redis and Memcached. And finally, Amazon Redshift, which is our managed data warehouse solution, provides you with petabyte scale data warehouse on the AWS platform. While each of the database options has its own strengths, it's important to understand that picking the best tool for the job is critically important. While we have many options from a database perspective, you also need to ensure that the database that you choose will be the best tool for your application needs and requirements. So let's start with Amazon RDS. Amazon RDS provides a fully managed relational database experience where you can run your traditional relational data stores, providing you with fast, predictable performance and simple and fast to scale. At the same time, it provides you for a low cost, pay for what you use. So typically when you're running development or test database, you can simply turn off your database, and then whenever you need it, back it up, you can always turn it on. So you are only paying for the amount of time that you're running your database. You have the option to run commercial database engines such as Oracle and Microsoft SQL Server on our RDS platform, as well as any open source database engines such as MySQL, Postgres, Maria, and our own Amazon database, Amazon Aurora. The typical use cases where you'd consider to have a relational database is for traditional e-commerce based applications, enterprise websites, IT solutions, reporting, and gaming databases. So wherever you need a relational database that you can take advantage of, either commercial database engines or open source database engines, you can run that on our Amazon RDS platform. The feature matrix here compares various capabilities across each of the database engines that are provided on our RDS platform. As you can see, each of those capabilities are available pretty much on all of the supported database engines on the AWS platform. For example, you can easily scale the underlying database instance on any of the database engines from a lower instance type, for example, M or T type, all the way to C and R type engine instance. Similarly, all of the engines today on our RDS platform supports encryption at rest. That means you can securely store your data at rest on our RDS platform. We also provide various capabilities for you to replicate your database across regions within the same region, and also use read replicas that can be used for your reporting database in case you need to spin up a second or a third copy of your database. You can also notice that we support various storage capacities for each of the database engines. And as you can see, Aurora engine supports all the way up to 64 terabyte capacity for your database. Each of the database also supports auto scaling, in which case you can take advantage of the scalable elasticity nature of the RDS platform. Amazon RDS is simple and fast to scale. So when you launch a database engine on RDS, you have to select the database instance type that you want to run. So you can easily select the required or the desired database instance type through the AWS console or through the AWS APIs or CLIs by specifying the instance type that you want to run your database engine, and also select the required storage type based on your database performance. We support general purpose SSD based on solid state drives for most production workloads. You also have the option to select provisioned IOPS, which is again based on solid state drives, but also it provides you with consistent IOPS performance where you will be able to specify the desired number of IOPS that is required for your database, and that will be provisioned for you when you launch the database engine. Finally, you also have the choice to select magnetic, which is based on spinning disk for any workloads that require infrequent access, or maybe for running your development and test small database engines that you can easily take advantage of using magnetic disks. Amazon RDS provides high availability multi-AZ deployments. So when you launch a database, you'll be selecting the region where you'll be launching your database. Within that region, you have multiple availability zones that you can easily choose to run your database in a high availability mode. That means when you select a high availability feature or a multi-AZ checkbox when launching your database, the database will be automatically provisioned across multiple availability zone, where your primary database engine for read and write will run on an availability zone A, and then the standby database engine, which will be replicating all the data into, will be run on a second or a third availability zone. When you choose the multi-AZ feature within the database engine, the platform provides you with automatic failover capability, synchronous replication, wherein every write that is committed to your primary database will be synchronously written to the standby database in a different availability zone, so that when you require to fail over to the standby database, the database is fully updated, and then you can simply fail over and then begin to use the database. The failover is also automatic and seamless. That means when there is a primary database failure detected on an AZ, the platform or the RDS platform will immediately detect that failure and then switch the standby to be the primary database. There is no changes required from your application perspective because it uses the same name for you to begin using the new standby database as your primary database for your application transactions. You can also choose read replicas for greater scalability. You can choose to run your read replica within the same region, or replicate or have your read replica entirely to a different new region. For example, you can run your primary database in US East region, and you can choose to have your read replica run maybe in US West or Europe region or any region within the Amazon platform. So that means you not only are bringing your data closer to your customer applications in different regions, but also relieving your pressure on your master node for supporting read activity. That means your primary database can be only used for reads and writes, whereas your read replicas that are spread across multiple availability zones or multiple regions can handle the additional read workloads for your application. In addition, you can easily promote a read replica to a master for faster recovery. So let's say your application is a cross-region application or a geo-supported application where you have your application running across multiple AWS regions, and then you have your read replica running in a different region. When the primary database running in a region goes offline for any reason, or you lose connectivity to a region, the read replica can easily be promoted through a single click or through an API call, and then that becomes a master, and then you can continue to have your application in that region access the database for read and write. As I mentioned, you can choose cross-region replication for enhanced data locality as also for faster recovery in the event of a disaster. You're not only bringing your data closer to your customer across different regions, but you have the ability to promote to a master for easier migration. So consider all the possibilities when you are building your application across region. Make sure that you can leverage or take advantage of cross-region capabilities that are available on our RDS platform. You can also actually have a snapshot and then use the snapshot across region for even greater durability, right? For some applications or for some enterprise workloads, you have a requirement wherein you need to maintain a snapshot copy of a database completely in a different region. Maybe for your compliance requirements, for your DR backup requirements, you have a need to store your snapshot in a different region. You can easily accomplish that on our RDS platform. In terms of RDS backups, there are two ways where you can take backups. One is through automated backups, wherein you simply select the required number of backups or the retention period you want for your database, and then that will be enabled by default. You can choose a retention period all the way up to 35 days. With manual snapshot, you can actually initiate your own snapshot based on when you need it. Although it says manual snapshots, it's still a single API call to generate a snapshot of your database, and then you can persist that database snapshot, which will be stored on Amazon S3 until you delete them. So you have the flexibility and choice to choose automated backup or manual snapshot, or actually you can take advantage of both depending on your application requirements. The cost for running RDS or database on our RDS platform is dependent on the resources that you are using for your database. That means the duration for which the database instances are used, and each of the database instance has a different pricing mechanism, plus the storage consumed, right? We also provide a free tier for the first 12 months wherein you can use the database instance type with the appropriate storage to completely take advantage of the free tier without paying for any of the database cost. We also provide up to 10 million IO operations within the first free tier for the first 12 months. So a lot of cases, a lot of our customers take advantage of this free tier to run their database workloads for the first 12 months and then move to a different tier or a different instance type beyond the 12 months. We have various customers that are leveraging RDS today, namely Samsung, Fairfax Media, Intuit, and then a whole lot of other customers that are taking advantage of our Amazon RDS platform to run their production database workloads on our Amazon RDS platform. In addition, you can also refer to our Amazon portal for case studies and white papers where all these customers have provided detailed case studies in how they've architected their database on our RDS platform. Now let's move on to Amazon DynamoDB. Amazon DynamoDB provides a fully managed NoSQL database experience wherein you will get single-digit millisecond latency for your application that are accessing Amazon DynamoDB. DynamoDB provides you with low cost, at the same time, massive scalability, where you can simply specify the appropriate read and write capacity units for your database, and then scale the database based on your application requirements. It requires no underlying maintenance or management for you to maintain and manage the underlying instances or the hardware for you to run your DynamoDB. DynamoDB supports both managed document as well as key value store. So wherever you require key value store, JSON document store, you should think of leveraging DynamoDB for your needs. It's very simple and fast to deploy. You can get started in using DynamoDB in less than 5 to 10 minutes by specifying the appropriate read and write capacity units. You don't need to specify how much capacity of storage you require. You don't need to specify the instance type. All that will be managed by the underlying DynamoDB platform and then be provided to you so that you can simply start creating your table sets, data structures on DynamoDB, and then begin to use that or leverage that for your application. The data stored within DynamoDB is automatically replicated across 3 availability zones in a region. So in which case, you actually don't need to account for any additional backup restore mechanisms as well. The data is safely protected across multiple availability zones in a region, in which case it provides you with fast, predictable performance, and all the data that is stored on DynamoDB is backed by solid state drives. In addition to that, in order to improve your query performance or indexing, you can take advantage of our global and local secondary index that offer fast lookup for performance. There's no cost to get started, so you're only paying for what you consume. Some of the popular use cases, as I mentioned, since it's a NoSQL data store, is especially in terms of ad tech, ad serving use cases, wherein you need to store ID lookup, user profile, or session tracking for your advertisement. You can simply take advantage of DynamoDB. DynamoDB is also very popular in IoT use cases or IoT solutions where you need to maintain all the devices' state metadata, readings from millions of devices, and other notifications. DynamoDB is also very popular for gaming and mobile and web applications where you can store session details, personalization, and also game leaderboard settings within your gaming application. As I mentioned, it provides automatic replication. You don't have to enable it. It's available by default when you begin to use your DynamoDB tables. So the writes are replicated continuously to 3 availability zones. The read, when you specify, you can actually go for either strongly consistent reads or eventually consistent reads. There is no latency trade-off in either of those cases. Let's take a quick look at how the structure is organized within a DynamoDB database. When you're comparing that with a relational database, right? With a relational database, you have table you have rows and columns. With the DynamoDB, you still have the concept of table, but in place of rows, consider rows as items, right? And then the attributes, which are essentially name value pairs, comprises of columns. Here, unlike with the relational database where you have a common column based, here with the DynamoDB, you can have different columns with each of those with different attributes. That means you can have a different name value pair for each of the column, and you're not bound by strict schema regulations as defined or as required for a relational data store. So the only thing that you require in order to get started with the DynamoDB is a hash key. Hash key, consider this as your primary key or index key, whatever you want to assume that. But hash key, where you probably think of it as something like an employee ID, which has high cardinality, unique data structures. Those will be your hash key. And that's the only requirement to get started with creating a DynamoDB table. You can also have an additional or optional range key. Assume range key as something like maybe a date range. For example, if you're building an employee database, consider employee ID as your hash key, which has unique IDs there. And then range key can be your date range where the employees have joined based on a date range, right? In addition to that, you can optionally also have a local secondary index. Those are your alternate range keys, in which case, if you want to further filter the data sets or improve your performance, query performance, you can actually build a local secondary index where you can have an alternate range key. Maybe consider that as maybe a department or a business unit function, right? So when you're querying, select star employee with for all business unit equals finance or something like that, right? So those can be your local secondary index. So thereby you're actually filtering your data set, wherein when you're querying for data within a DynamoDB table, you're not incurring the additional read penalty where you have to read all the data structures within a table, where you can easily sort through a range of hash key or a range key or an optional local secondary index key as well. We also have what we call as global secondary index. Global secondary index is a completely unique index of its own, while local secondary index is tied to your main database DynamoDB table. Global secondary index is a completely different index table that's stored separately from your DynamoDB primary table. In which case, if you want to query or project attributes completely apart from what you're querying from your primary database data structure, you can take advantage of global secondary index. This provides you with very high optimal performance where you're only querying a subset of data that does not impact your primary database stored on your primary tables. So all you need to do is when you're actually building your DynamoDB table, you are defining the desired performance, right? There are two knobs where you can alter based on your read and write capacity units. And that's all is required. When you actually create a DynamoDB table, you specify the primary key, and then you specify how much read and write capacity units you require. And that's about it. If you are able to map your application to how much the transactions per second that you require, and that's all you require. You don't need to select the instance type. You don't need to select the amount of storage needed. All those are automatically provisioned for you on the platform at the back end. So what are those capacity units? One write capacity unit will allow you to write 1 KB of write per second, right? So you can imagine that if you're writing for 1 KB of data per second for 1 hour, so you calculate and then map out how much capacity units you require. Similarly, on the read capacity units, one strongly consistent read, you can read up to 4 KB or 2 eventually consistent reads per second. So you can choose based on your application requirement, whether you require strongly consistent read or eventually consistent read. Even between the two, we are talking about maybe sub-millisecond or a second latency difference between these two. We are not talking about order of magnitude of few seconds or minutes or something like that. The difference between a strongly consistent and eventually consistent is definitely in the range of milliseconds or up to a second. So for most of the use cases, eventually consistent reads would do well for your application. But if you require very core or intense transaction-based application that you're writing and you're reading that simultaneously, then you can choose the strongly consistent read for your application or for your DynamoDB table. A simple application architecture is described here where you're using the DynamoDB table as your backend data store. So your clients, clients are reading through an elastic load balancer, which distributes your application traffic on a group of Amazon EC2 instance that is running the business logic, and the actual data structures or the data store is stored in a DynamoDB table in the backend. So that way, your application architecture is similar to how you typically build with a 3-tier architecture, right? You have your front end, you have your application tier, you have your data tier. It's exactly the same, only in the case here, you're replacing your relational database with the DynamoDB or a NoSQL data store here. So you don't need to really alter or refactor your application architecture significantly in order to take advantage of DynamoDB data stores. From a cost perspective, this is how the billing works. So you're billed for the storage that you're consumed, right? So for example, 5 GB, you're billed for the 5 GB of data that you're consuming, and then you're again charged for the write capacity units and the read capacity units. So you accurately get the estimate of cost when you are specifying the read capacity units, the write capacity units, and the storage consumed, right? So here, as an example calculation, you're using 5 GB of the storage, and then you specified 21 and 35 write and read capacity units respectively. So the total cost for you to run a DynamoDB data structure using these requirements will cost you about $14 a month, right? So you get very accurate costing of how much you're consuming based on exactly how much you're specified for your read and write capacity units. In addition to that, DynamoDB also offer you the free tier for the first 12 months, wherein you get 25 GB storage and 25 read and write capacity units for the first 12 months. So if you're actually calculating that for the first 12 months, you will end up paying less than $1 per month for the first year. So you can imagine the possibilities that you can take advantage of DynamoDB table for the first 12 months for your application. And even after that, based on how much you are consuming based on a read and write capacity units, the cost is very transparent for you, and the cost is very low for you to easily scale and build your application. We have various large enterprise customers who are using DynamoDB today. As you can see, we have a variety of customers listed here. In addition to that, you can also go to our portal and look for various customers who are taking advantage of DynamoDB. You can also browse through our YouTube Amazon Web Services channel to look for customers who have come and presented at reInvent based on our DynamoDB use cases. So I think often application teams are challenged as to how do you make a determination when you want NoSQL versus SQL, right? So there are various attributes that depends on your application, but we try to give a high-level overview of when you want to maybe consider NoSQL versus SQL, right? So if your application or your data structure is schemaless, where you don't need to maintain very strict data structures, right? Or if your data structures you're not completely aware of when you're building your application ahead of time, or you think your data structure is very dynamic nature. For example, when you're building big data streams, or when you're consuming big data streams, you are consuming data from various data sources, from IoT to big data to maybe your application logs. You'll probably not have a good idea of how to structure a database, in which case it is easy to begin using NoSQL database and then add on to building additional schema within the NoSQL database. Scaling is very easy, as I mentioned. You don't need to plan for scaling. You can easily scale. Even if you say, let's say, for example, at the beginning of the database, when you create a DynamoDB table, you specify maybe 100 read capacity units and 100 write capacity units, right? And probably that's your guess at the beginning of the data table when you create. And after that, in case you need to add additional read and write capacity units, you simply specify the additional read and write capacity units that you require. You don't need to restructure your database. You don't need to rebuild your database, or you don't need to migrate or move to a different instance type. Scaling is very easy and automatic on the NoSQL database. Focus on performance and availability. When you think about ACID properties, right? Here you're focusing on more performance and availability. Whereas when you choose with the SQL database, you're looking for strong consistency, right? Or scale and availability. When you require strong schema, or when you have complex relationships, transactions, joins across various entities within your data structure, probably SQL database would be a good candidate for that. However, as we all know, that scaling can be a little bit challenging when you want to scale horizontally, right? There are various ways when you can scale relational database. Horizontal scaling, where you can add more CPU and memory capacity, or horizontal scaling when you are adding additional nodes. While it's not impossible, where we have customers who are scaling their relational database, but it probably can be challenging, or it can require downtime or additional complexities when you are building your data structures. Now let's move on to Amazon Redshift. Amazon Redshift provides you with a managed relational data warehouse experience. Redshift provides you with a massively parallel petabyte scale data warehouse. It's a fully managed database or a fully managed data warehouse experience. You have the choice to choose whether you want to go for a high performance solid state drive platform, or simply with a magnetic drive, in case you have petabyte data where you're not required to have high performance, but you're required to incur or ingest your data across various data stores on a petabyte scale. The cost is very transparent there. You can start with like $1,000 per terabyte per year. And we have various cost mechanisms that we'll walk through in a bit as well. So typically, when do you want to use Amazon Redshift is for traditional enterprise data warehouse, where you want to reduce cost by extending your existing data warehouse rather than adding additional hardware to sustain additional data warehouse workloads, right? Or you might want to completely migrate from your existing data warehouse to the AWS cloud, and you want to take advantage of Redshift. We have various companies that are taking advantage of Redshift today to improve their performance by an order of magnitude, and then also access business data while using standard reporting tools. So if you've already invested heavily in your visualization tools, BI tools, object tools, right? You don't need to change or replace any of those tool mechanisms. All of those business objects or all of those visualization reporting tools will be supported on Redshift. You simply plug in with an ODBC driver and then connect to the Redshift platform. A quick look at the Redshift architecture. We have the concept of what we call as a leader node. A leader node is a simple SQL endpoint. That is your entry point for all your JDBC, ODBC connection from your client side connecting into the Redshift. The leader node is responsible for storing all the metadata. It also optimizes the query plan that is actually executed on the compute node themselves. So the leader node actually coordinates query execution among various compute nodes. And all this is backed by a high 10 gig E backend fiber connection between the leader node and the compute node. The compute node utilizes local columnar storage that improves I/O performance, and all the queries are distributed in parallel across various compute nodes within the Redshift cluster. You can grow up to a 2 petabyte compressed, and then you have various options. As you can see, if you want really high performance data store, you can choose the solid state drive that can go all the way up to 326 terabyte, or you can go with the hard drive option where you can scale to as much as 2 petabyte. In addition to that, Redshift easily plugs in with various other Amazon services such as Amazon S3, DynamoDB, EMR, where you can easily take advantage of integration between various other AWS services for ingestion, backup, restore mechanism as well. We all understand, I think, one of the important aspect in driving high performance out of your data warehouse or your database is to focus on your I/O, backend I/O. So with columnar storage, with traditional relational data stores, you're storing your data in a row fashion, right? That means it's a row storage where you have column-based and row storage. With Redshift, all your data is being stored in a column storage where you're not utilizing the row storage to do unnecessary IOs. For example, let's say in this example, you need to get the total amount. In this case, the database has to read the entire data structure in order to get the total amount. Whereas in a column-based storage mechanism, you're only reading the required column in order to generate the total data or compute the total column sum here. So that drastically reduces the number of IOs required to perform at the database backend, improving your IO performance for your Redshift. In addition to that, all the data that is written to the Redshift is compressed. So we have various compression algorithms that support it. So when you are actually doing a copy from, let's say, S3 or various data sources using copying mechanism, the copy actually compresses the data automatically before it's being written to the Redshift cluster. You can also analyze and overwrite some of the properties there. So that means you're not only improving the IO, but also getting storing fewer data within the Redshift cluster. Zone maps are similar to index in the way that it can track the minimum and maximum value for each block. So when you write the data to Redshift cluster, the Redshift tracks the block where it's stored, right? And then it also computes automatically the zone maps. For example, the minimum value and the maximum value that you see here. For example, in the first case, where the minimum value is 10 for the block, the maximum is 324. So when you are actually reading the data from a Redshift cluster, the zone maps tracks all the blocks that are written and read into. So whenever you require a specific block, it actually goes to the zone maps and refers where the data block is stored and then gets the data back to you. So that means it's only reading a subset of data for you to provide, thereby again improving IO performance there. It skips over blocks that don't need the data to be read or doesn't contain relevant data. Direct attached storage. So Redshift uses direct attached storage that actually improves performance as well. So you get high performance, which is the disks are directly attached, and you get high disk density as well. So all these characteristics with Redshift make it a very popular data warehouse platform where you can not only generate high performance, but also be able to store and be able to leverage Redshift for your data warehousing requirements. With Redshift, you also get fully managed continuous incremental backups. That means as the data is being written, the data is being actually backed up to S3, and you can actually copy the data from one region to another for backup and restore in case you need to use multi-region approach for your backup capabilities. So Redshift offers rock solid fault tolerance across regions, and then it handles any disk failure, node failures where the Redshift platform is able to rehydrate the disks or the nodes back into the Redshift cluster, thereby minimizing any of the failures that occurs on the Redshift platform. You pay for what you use exactly like other services. You're only billed for the number of nodes and the duration for the nodes which were used. We have a large ecosystem of partners that are well integrated with Redshift. Thereby, you can, if you're using any of the BI tools, data integration tools today, you can easily integrate with Redshift platform today. We also have numerous customers that are taking advantage of Redshift to run their data warehouse applications. As I mentioned, you can also take a look at a portal to get more detailed perspective from each of those customers on how they are leveraging Redshift for their data warehousing needs. And finally, we are going to take a look at Amazon Elasticache. In the interest of time, I'm going to quickly move through some of the slides here. Elasticache provides you with a high performance in-memory key value store. So we are talking about high performance in the order of nanosecond performance here, right? Or microsecond here. So while DynamoDB also provides you with a NoSQL data store, which provides you with a millisecond response time. Amazon Elasticache is based on microseconds. So that means if you require higher performance for your NoSQL data store over and beyond what DynamoDB can provide, you can choose to go with Elasticache, which provides in-memory caching. So keep in mind that it's not just a caching layer for your database, underlying database. It also provides you with data structures as a NoSQL data store where you can store your key value data structures on Elasticache and simply use this as a NoSQL data store and get high performance requirements or high performance from your Elasticache clusters. Some of the use cases involve popular leaderboards and other various mechanisms where you require high performance requirements for your data structures. And both of these are fully managed. In addition to that, you also get multi-AZ auto failover capabilities with Redis clusters as well. You can also launch read replicas with Redis, where you can take advantage of read replicas in order to build data structures capabilities across read and write replicas. A simple architecture here represents where you're using Elasticache in front of your Amazon RDS, and you have your traditional EC2 instances that are handling your workload coming in from the user. So again, as you can see that the caching improves read performance for your application, and then all the writes go back to your traditional relation data stores. By building resilient application architecture across multiple AZ, you're able to not only take advantage to improve your read performance for your database, but also be able to elastically scale across multiple AZs and still able to take advantage of high availability capabilities that you can build with your application architectures. The billing for Elasticache is similar to the way that we have seen before. You're only billed for the number of nodes and the duration for which you're using the nodes. We also provide free tier for the first 12 months, where you can take advantage of the free tier to build your application and take advantage of caching capabilities. Here you can see various Elasticache customers that are using for their application workloads. Expedia uses Elasticache Redis in order to provide you with high performance application. And various other gaming solutions, for example, Riot Games and other applications that are also taking advantage of Elasticache today on AWS platform. So tying it all together, we walked through various configuration aspects with relational database, when to use it, DynamoDB, which is NoSQL database, Redshift, which is a data warehouse, and finally Elasticache, which is an in-memory key value data store or a caching database. So if you want to tie this all together for your application, you can do so where you get not only high performance, but also be able to select the right tool for the right job, right? Here you're using your Elastic Load Balancer, and then you have your traffic distributed to the backend database EC2 instances, backend EC2 instances where you have an application logic, and you can actually store your maybe your data connections or other temporary attributes in a DynamoDB table, right? Or session connections, session settings in a DynamoDB table. And then you can use Elasticache to improve read performance for your backend database. The backend database, as you can see, you can use a multi-AZ relational database, as I mentioned, where your primary database will be residing in an availability zone, and then the slave or the standby database will be in a different availability zone. So in case the primary database, for whatever reason, goes down or you lose connectivity to that database, the standby database will be promoted as a primary database, and then your application transactions would continue uninterrupted. Finally, you can actually ingest data or copy data using various mechanisms from your relational database to Redshift cluster for offline data analytics or data warehousing requirements for your business analyst or other users. So if you're tying all this together, you get a high availability architecture, but also a high performant architecture where you're choosing the right tool for the right job. From a next steps perspective, we highly encourage you to take advantage of the free tier that is available in each of the platform capabilities so that you can build your first application or your second application on the AWS platform, and then run this for whatever time you require for up to a year, and then go with the next year that requires that will suit for you in terms of moving to a different tier. Finally, I'm going to leave it to you with a few important links that you can actually navigate to in order to explore additional details, additional capabilities for each of the options that we went through. You have various white papers, you have various documentation that we have provided here. The database migration service provides you with various detailed capabilities of how you can actually migrate your database workloads from your existing data center to AWS as well. That's a pretty good white paper. In addition to that, we have provided various best practices for running Oracle database on Amazon Web Services and migrating relational database to a NoSQL database like DynamoDB. So those are pretty useful links. And then we encourage you to take a look at these links, explore, and then come back to us if you have any additional questions.